any two desirable characteristics have an inherent trade-off between them, even if you never see it, right? There are reasons you wouldn't see it, but that if you push these things far enough, you'll find that there are no desirable things that can be components of the same mechanism that will not exhibit a trade-off relationship, right?
This is interesting. Initially, I don't agree with that at all, but I'm sure you've thought about it a lot, so I'm curious why you say it.
Well, let me give you the example I used to battle my friend Scott Pecure over with this, which is he said, "Why can't you make a car that's the fastest and the bluest?" Right? And the first time I heard that, I was like, well, okay, maybe blue is trivial enough, but it's not. In fact, if you wanted to make a car that was the fastest, and by fastest, let's say fastest accelerating, well, you're going to have to decide how to paint it. If you also decide that there's some color of blue that is bluest, and you want the car to be that color, well, then it has done a lot of the choosing of what paint you're going to put on it at the point you decide to paint it that color. That paint will have components that will weigh something, right? The chances that the bluest, whatever you define that to be, is also the lightest and has the best laminar flow characteristics are essentially zero, right? Because they're an infinite diversity of colors. They will be made out of a wide variety of materials, and the chances that the blue just happens to be the one that is lightest and has the best, slipperiness relative to the wind are going to be vanishingly small. And that means that if you want to make truly the fastest car, its color will be chosen by whatever paint has the best characteristics. And if you want to make it the bluest as well, you'll make some tiny compromise that will probably not matter to you, but it's there. So the trade-off is there even if we don't see it. But here's the thing, Daniel. I discovered many years after my argument with Scott was long since put to bed that I was right about this. And the way I found out was that there is a case where the Navy wanted to set the time to climb record for an aircraft. And they took an F-15 and they souped it up a little bit. And in order to set basically the vertical climb rate of this aircraft, they stripped the paint off it. And so if you look at pictures of this aircraft in its record-setting run, it isn't any particular color. It's many different colors because effectively you've got the bare metal underneath with the paint stripped off it to save however many pounds of paint they were able to remove.
Okay, there are 3 points that come up to address my initial thoughts on this here. So one is, with this particular case of a car, the difference between the blue and the optimal color might be at the boundary of measurement itself.
Yep.
And so while it's true that it might not be a perfect optimum of both at the level of like a nanoscale optimization, it is irrelevant to the scale of choice making for the most part. And when we look at something like
100%.
And when we look at something like Tesla cars that became faster off the line than Ferraris and safer than Volvos and greener than Priuses at the same time, you could see that ground up design, just doing a better job of ground up design, was able to optimize for many things simultaneously so much better. Now, had they made it less comfortable, could it be faster still? Sure, of course. So it's optimizing for a product of a bunch of things together, but still in a whole different league than things had been previously. Now,
wait. First of all, this is beautiful, okay? Because this is exactly what I was hoping for, okay? This is a question of us tripping over each other's language. Jim misunderstood what you were saying, right? And he asked me about it, and I said, yeah, Daniel can't be right about that if he's saying what you think he's saying. But of course, it wouldn't make sense that you would think that you could. So your point about this being trivial, you're in complete agreement with me, and I suspect it would take nothing to get Jim to agree to that formulation as well.
Wait, there's a difference. There's one more thing I have to say here.
Okay.
Of course, I'm not pretending that thermodynamics don't exist, right? And that once you get down to the quantum scale arrangement of a thing, that orientation in one direction doesn't have effects on other things. Duh.
Yep. There's
a difference also between blue and fast are two different preferences that are arbitrary, that both want to be associated with a car, that don't have some intrinsic unifying function. And we can say blue is a thing that's reasonable to be preferential about color. Whereas I would say that there are some characteristics that have a synergistic effect, that increasing one increases the other one because of the way they are part of a overall increase in system integrity. And so synergy is the key concept I'm trying to bring about here, which is behavior of whole systems more than the sum of and unpredicted by the parts taken separately. So when I say I'm looking for synergistic satisfiers, the idea that I have X amount of input and that input has to be divided between these various types of output and it's linear is nonsense. I can have X amount of input and have something where the total amount of output has increased synergy based on the intelligence of the design. But the question of how do we design in a way that is optimizing synergy between all the things that matter becomes the central question.
Yes, which is, of course, the central question that selection must be dealing with in generating complex life. And I don't think we have a hair's breadth of difference on what we turn out to believe about this trade-off space. But what I would say is, and I don't want to drag the audience too far down this road, it's probably not worth it for what we need to do here, but the benefit of being able to say, so let's take your example of there are certain characteristics that will co-maximize. Not really, because of the following thing. Let's say that we figure out what color is best for making the fastest car. And then we say, well, I want to maximize gray 37 and speed. Now I can do it. I can maximize gray 37 and speed because it just so happens that gray 37 is the color that has the best characteristics for speed, right? But then the point is you can't separate these two things. Whatever characteristic it is you're actually maximizing, you've just found two aspects of it. So your point about synergy is that perfectly aligned characteristics, yes, we could describe that joint, that fusion of those two things as one thing, and we could maximize it, right? But then if we take the next one over, right, the next characteristic that we want to add to the list of things, then again, we're back in trade-off space. So my only point here is that there is a value in order to be able to get the maximum power out of a trade-off theory. What we want to do is make it minimally complex, and the ability to say every two desirable characteristics have a trade-off between them. The real question is the slope or the shape of the curve, right? And that many of these slopes and shapes mean we will see no meaningful variation on it because one side is a bargain and we will always see that manifest, right? That's the reason we don't see trade-offs everywhere, is that in some cases a trade-off is so dumb that we don't see anybody exercising variation. Everything has made the same decision.
Yes, and I think for all practical purposes, we agree that being able to make a Tesla that is safer than a Volvo and faster than a Ferrari and greener than a Prius is a possibility, and that we can, if we applied that to all of the problems in the world, we could do a fuck ton better job.
Yeah.
I think we also agree, and I love the last point that you made, that to the degree that two things can be simultaneously optimized, they can be thought of as facets of a deeper integrated thing.
Yep.
Okay, so now to answer the way that I actually think about it, though this is irrelevant, if people disagree, it doesn't matter at all to the earlier point. I have to wax mystical a moment. When Einstein said it's a optical delusion of consciousness to believe there are separate things, there's in reality one thing we call universe, and everything's a facet of it. If I look at the real things that we have theory of trade-offs between in the space, in the social sphere and the associated biosphere that we're a part of. So let's say we talk about, in the very beginning of our conversation, individual. What would optimize my individual well-being, and what would optimize the individual, and what would optimize the well-being of all humans? I believe that I only find that those are differently optimized if I, again, take a very short-term focus. If I take a long-term focus, I find that they are one thing, because the idea that I'm an individual and the idea that humanity is a separate thing is actually a wrong idea. They're facets of an integrated reality. And that if I factor all of the things that are in the unknown set over a long enough period of time, they're simultaneously optimized. And this is the essence of dialectical thinking, is looking for the thesis and the antithesis and not voting between thesis and antithesis, but seeking synthesis that's at a higher order of integration and complexity.
Totally agree. And, so I don't know how many people will be tracking it, but, effectively saying on a indefinitely long time scale, these things converge is an acknowledgement that we are not talking about design space when we make this recognition, right? It's more like trajectory. And that is perfectly consistent. And frankly, I think if everybody understood at some level the kind of picture we're painting, people would be really comfortable with the degree to which it doesn't do exactly the thing they most hope it will, right? In other words, the level of compromise is small, right?
Which is why the compromise in a healthy democracy even was tolerable, even though that was nowhere near as optimal a system as we could develop.